Good morning, children. Today we are going to say 8th question from first exercise. Listen. If PO vector plus OQ vector is equal to QO vector plus OR vector, prove that the points P, Q, R are collinear. We want to prove these 3 points are collinear. To prove P, Q, R are collinear, it is enough to prove PQ vector is equal to QR vector. So that is our aim. First we take our given condition. Can you tell me what is the given condition? Yes. The given condition is PO vector plus OQ vector is equal to QO vector plus OR vector. So which is given. Okay. Here given condition PO vector plus OQ vector is equal to QO vector plus OR vector. Here OQ vector, what is meant by OQ vector? Yes, the position vector of Q with respect to origin O. It is in the standard form. But PO vector is not in the standard form. So to make the standard form, let us rewrite. That is PO vector is equal to minus OP vector. Okay, similarly come to right hand side. Here OR vector. OR vector means what? Yes, the position vector of R with respect to origin O. Yes, it is in the standard form. But the QO vector is not in the standard form. How to make standard form? Yes, reverse it. That is QO vector is equal to, yes, minus OQ vector. That's all. So that is our preparation. Again, OP vector, OQ vector and OR vector fixed. And PO vector and QO vector we want to interchange for our convenience. Now listen, OQ vector, write as it is. OQ vector as it is. OQ vector as it is. Now, PO vector is equal to, yes, minus OP vector. Minus OP vector. Okay, which is equal to, here, QO vector. Oh, yes, we want to rewrite. QO vector is equal to minus OQ vector. But OR vector, yes, is in the standard form. First write OR vector as it is. OR vector as it is. Now, QO vector is equal to, yes, minus OQ vector. Okay. Next step, yourself. Yes. OQ vector minus OP vector is of the form? Good. Second minus first. Second minus first means here second minus first. There were capital P is the first point and Q is the second point. So OQ minus OP is equal to PQ vector. So which is equal to second minus first. Therefore PQ vector. Okay, which is equal to. If your doubt means how to verify? Yes, verification is very simple. PQ vector equal to second minus first, which means PQ vector is equal to OQ vector minus OP vector. Yes, PQ vector is equal to OQ vector minus OP vector. Therefore, OQ vector minus OP vector is correct. Okay, similar way, what is right hand side? Yes, is of the form second minus first. OR vector minus OQ vector is of the form second minus first, which means first Q, second R. So, OR vector minus OQ vector is equal to QR vector. So, which is equal to QR vector. That's all. Okay, verification? Yes, that is QR vector is equal to OR vector minus OQ vector. Yes, we get a before step. So, clear? Now, PQ vector is equal to QR vector. Here, PQ vector and QR vector are equal. And they are equal and equal in magnitude. Now, listen, let us draw the diagram for our convenience. Listen, initial point, capital P, suppose capital Q, and let it be the last point is R. That's all. Now, from the before step, PQ vector. Where is PQ vector? Yes, P to Q, PQ vector. Next, QR vector. Where is QR? QR vector means what? Yes, Q to R. So QR vector is equal to Q to R, which is QR vector. Now, what can you say about these 3 points? Here, PQ vector and QR vector are, yes, they lie on the same line. And, yes, they in the same direction. Here, PQ vector and QR vector are lie on the same line and in the same direction. Therefore, very good. the two vectors are parallel. Here PQ vector is equal to QR vector, and the PQ vector and the QR vector are lie on the same line and in the same direction. Therefore, P, Q, R are collinear. Consider here Q is the common point. That is very important. Now write theory portion. Listen, step 1. Step 1 is here PQ vector and the QR vector are lie on the same line and in the same direction. Here PQ vector and QR vector are lie on the same line and in the same direction, or lie on the same line and in the same direction, Okay, next step. Here PQ vector and the QR vector are lie on the same line and in the same direction. Here Q is the common point. That is important. Here Q is the common point. Here Q is the common point. Okay. Here Q is the common point. Therefore, P, Q, R are collinear. Therefore, P, Q, R are collinear. Okay. Listen, its preparation is very simple, which is 3-mark question. PO vector plus OQ vector is equal to QO vector plus OR vector is given condition. Now, OQ vector and OR vector are in the standard form, but PO vector and QO vector are not in the standard form. So, we want to interchange. That is, PO vector is equal to minus OP vector, and QO vector is equal to minus OQ vector, where OQ vector and OR vector are fixed. That's all. Now E is of the form second minus first. Yes, second minus first. And it is of the form second minus first. Therefore, PQ vector is equal to OQ vector minus OP vector. QR vector is equal to OR vector minus OQ vector. We get before step. Now draw the diagram. Here PQ vector and QR vector, they lie on the same line and in the same direction. Therefore, here Q is the common point. Therefore, P, Q, R are collinear. Okay, which is 8th sum 3-mark question completed. Now come to 9th question from same exercise with the same page number. 9th question, page number 16. If D is the midpoint of the side BC of triangle ABC, then prove that AB vector plus AC vector is equal to 2 into AD vector. Listen again the question. If D is the midpoint of the side BC of triangle ABC, then prove that AB vector plus AC vector is equal to twice of AD vector. This result we want to prove. Okay, what is the given keyword? Yes, the given keyword is a triangle ABC. In triangle ABC, D is the midpoint of BC. In triangle ABC, D is the midpoint of BC, then prove that AB vector plus AC vector is equal to twice of AD vector. This result we want to prove. Okay. First, the given keyword is a triangle. First, let us draw the triangle ABC. Listen, in triangle ABC, listen, given that in triangle ABC, D is the midpoint of BC. Yes, in triangle ABC, D is the midpoint of BC. So that is a condition. Yes, D is the midpoint of BC, where D, which is midpoint, okay, which is given data. Then prove that AB vector, listen, in the diagram, where is AB vector? Can you tell me where is AB vector? Yes, AB vector means, yes, A to B. So AB vector, listen, AB vector, which is AB vector? Yes, AB vector plus AC vector. Where is AC vector? AC vector means, yes, A to C. That is AC vector. So we want to prove AB vector plus AC vector is equal to twice of AD vector. Where is AD vector? AD vector means, yes, A to D. AD vector means A to D. So AD vector. So we need AD vector, therefore join AD. That's all. Join AD. Okay. Now we want to prove AB vector plus AC vector is equal to twice of AD vector. This result I want to prove. Okay. We can prepare mind itself. Preparation is very simple. First consider AB vector. Listen. A to B, straight route. Okay. What is the next way? Yes. AB vector is equal to AD vector plus DB vector. Okay. And to get the first term, we want to consider the triangle in triangle ABD. In triangle ABD, by the triangle of addition of vectors, AB vector is equal to AD vector plus DB vector. So first we want to consider the triangle ABD. In triangle ABD, by the triangle of addition of vectors, AB vector equal to AD vector plus DB vector. Yes. First equation is ready. Come to second term. Yes, what is second term? AC vector. AC vector. To get the AC vector, which triangle I want to consider? Yes. In triangle ADC. In triangle ADC. Now I want to consider the second triangle. In triangle ADC, AC vector equal to, yes, AD vector plus DC vector. So it is a DC vector, that's all. So first equation, AB vector equal to AD vector plus DB vector. Second equation, yes, AC vector equal to AD vector plus DC vector. Second equation. Now I want to add or subtract? Yes, I want to add. Adding 1 and 2, we get the required result. So it is our A. Okay. Now, below the diagram, write the to prove. To prove. What do we want to prove? Yes, we want to prove AB vector plus AC vector is equal to twice of AD vector. Yes, this result I want to prove. Okay. Now come to the first term AB vector. Now listen. Now AB vector is equal to AB vector is equal to AB vector is equal to AB vector equal to AD vector plus DB vector. And in which triangle you want to consider? In triangle ABD. So in triangle ABD, one can write here. In triangle ABD. In triangle ABD, AB vector is equal to AD vector plus DB vector. AD vector plus DB vector. Let it be the first equation. First equation is ready. Okay, now, what is the second term? Yes, AC vector. And how to find the second term? That is, second term AC vector lies in which triangle? Yes, in triangle ABC. Now, in triangle ACD. In triangle ACD or ADC. So let us consider ADC. In triangle ADC, AC vector is equal to. Okay, now yourself. AC vector equal to, yes, AB vector plus DC vector. AD vector plus DC vector. Okay. Now, in the diagram, what can you say about DB vector and the DC vector? Yes, they are equal in magnitude. Because, why? Because equal in magnitude? Yes, midpoint. Here, DB and the DC are equal in magnitude. But, yes, opposite in direction. Here, DB vector and the DC vector are equal in magnitude, but opposite in direction. Therefore, DC vector is equal to minus DB vector. So therefore, listen, since DB vector or DC vector, one can write a DC vector, consider DC vector. DC vector is equal to, because second term here DC vector, here DC vector is equal to minus DB vector. Minus DB vector, that's all. Here DB vector and the DC vector are equal in magnitude but opposite in direction. Therefore, DC vector is equal to minus DB vector. So write DC vector equal to minus DB vector, which is equal to AD vector. Fix AD vector as it is. What is a DC vector? Yes, DC vector equal to minus DB vector. Minus DB vector, which is AC vector. Let it be the second equation. Okay, now come to the result. Whether I want to add or subtract? Yes, I want to add 1 plus 2. Adding 1 and 2. Adding 1 and 2 means, listen, first equation, second equation. And while adding LHS plus LHS. Can you tell me what is a sum of LHS? Yes, that is AB vector plus AC vector, which is equal to, yes, first term. What is first term? First term of the first equation, AD vector, plus second term of the first equation, DB vector. Okay. Now, first term of the second equation, yes, plus AD vector. Okay. Second term of the second equation, minus DB vector. Minus DB vector. Okay. Now, simplification yourself. Yes, how many terms are there? Yes, there are 4 terms are there. 1, 2, 3, 4. Okay, in which any cancellation? Yes, very good. Positive and negative cancel. Minus DB vector plus DB vector cancel. Minus DB vector plus DB vector cancel. Next, yes, 2AD. Here, plus 1AD, plus 1AD. So, totally twice of AD. So, which is equal to 2AD. Whose left hand side is AB vector plus AC vector. So, which is the result which we have to prove. So, hence proved. Hence proved. Children, listen. Now, to learn next question, we need a note. Listen, note. In triangle ABC, in triangle ABC, AD, comma, BE, comma, CF are the medians. Listen, to learn next question, we need a note. It is a concept for next question. In triangle ABC, let AD, comma, BE, comma, CF are the medians. Let medians meet in the point G. Let G be the meeting point of the medians. Okay. Now, let O be the origin. Let O be the origin. The position vector of where G is a centroid. The point of intersection of the medians is called a centroid. Good. Centroid. So, the position vector of G with respect to origin O is, yes, OG vector. OG vector is equal to, listen, OG vector is equal to OA vector plus OP vector plus OC vector by 3. So, OG vector equal to OA vector plus OB vector plus OC vector fully divided by 3. That is, which is equal to OA vector plus OB vector plus OC vector divided by 3. Centroid G is a pointer. Now, cross multiply for our convenience. Cross multiply. On cross multiplying, 3 times of OG vector equal to OA vector plus OB vector plus OC vector. One can rewrite also correct. That is, what is OA vector plus OB vector plus OC vector equal to? Yes, 3 into OG vector. Now, by cross multiplying, we get OA vector plus OB vector plus OC vector is equal to 3 times of OG vector. So, 3 into OG vector. So, this, the last step, we are going to use next step, next sum. So, that is why 3 OG vector is equal to OA vector plus OB vector plus OC vector. Conversely, OA vector plus OB vector plus OC vector equal to 3 into OG vector. Okay, note completed. Now come to next 10th question from first exercise. If G is a centroid of a triangle ABC, if G is a centroid of the triangle ABC, then prove that GA vector plus GB vector plus GC vector equal to 0 vector. This result we want to prove. Okay, what is the given key? Yes, in triangle ABC, that is important. First we draw the triangle ABC. In triangle ABC. In triangle ABC. Listen. In triangle ABC. In triangle ABC. Here GA vector. GA vector. Listen. From the before note. GA vector. So it is GA vector plus GB vector plus GC vector is equal to 0 vector. We want to prove. So here, see AD and BE and CF are the medians. AD, BE and CF are the medians. Given that G is the centroid of a triangle ABC, listen. The point of intersection of the medians is called a centroid. The point of intersection of the medians is called a centroid. Here G is the centroid of the triangle ABC. Then prove that GA vector plus GB vector plus GC vector equal to 0 vector. This result we want to prove. Okay. Now come to the question. Now let us take LHS of the question. Okay, take LHS of the question. The LHS of the question is now GA vector plus GB vector plus GC vector. Okay, which is equal to. And also let O be the origin. Let O be the origin. Origin is anywhere, let O be the origin. Okay. What is GA vector? Can you tell me what is GA vector? With respect to origin O? Yes, second minus first. GA vector is equal to second minus first, OA vector minus OG vector plus GB vector equal to, yes, OB vector minus OG vector, second minus first. GC vector equal to, yes, second minus first, OC vector minus OG vector. So that is a preparation. So GA vector equal to OA vector minus OG vector, OA vector minus OG vector plus GB vector is equal to, yes, OB vector minus OG vector. OB vector minus OG vector plus GC vector is equal to, yes, OC vector minus OG vector, second minus first. So plus OC vector minus OG vector. Okay. Now which is equal to. Now simplification yourself. Any idea to simplify? Yes. First collect the positive terms. Positive terms means OA vector, OB vector, OC vector are the positives. Write the positive terms first. So therefore OA vector plus OB vector plus OC vector. Okay, next is simplification. Yes, very good. 3 times of OG vector because minus OG vector, minus OG vector, minus OG vector. So totally, yes, minus 3 OG vector. So minus 3 OG vector. Okay, for our convenience, first bracket for the first 3 positive terms. Okay. Now which is equal to. What can we say about the moon bracket? That is OA vector plus OB vector plus OC vector equal to? Yes, very good. 3 OG vector from the note. So from the note we know that OA vector plus OB vector plus OC vector is equal to 3 OG vector from the before note. So the bracket is equal to 3 OG vector. Already minus 3 OG vector. Okay, now? Yes, 0 vector. Why? Yes, very good. Minus 3 OG vector plus 3 OG vector cancel. So which is equal to 0 vector. Therefore, GA vector plus GB vector plus GC vector is equal to 0 vector. Hence proof. Children listen. Now 11th question from the first exercise. Let A, B and C be the vertices of a triangle ABC. Let D, E and F be the midpoints of the sides BC, CA and AB respectively. Then show that AD vector plus BE vector plus CF vector is equal to 0 vector. Okay, first come to the what is the keyword? Yes, the keyword is a triangle. And given that, yes, A, B, C are the vertices of a triangle. So first draw a triangle ABC. In triangle ABC, listen, step 1. In triangle ABC. Yes. In triangle ABC. In triangle ABC, A comma B comma C be the vertices of the triangle ABC. First line. Okay. What is next? Let D comma E comma F be the midpoints of the sides BC, comma CA and AB respectively. Which means, yes, very good. D is the midpoint of BC. Next. E is the midpoint of AC or CA. F is the midpoint of AB. So let D is the midpoint of BC. Next. E is the midpoint of AC. E is the midpoint of AC. Next. F is the midpoint of AB. So F is the midpoint of AB. So D comma E comma F be the midpoints of the sides BC, comma CA and AB respectively. Okay, second line over. Then show that AD vector plus BE vector plus CF vector equal to 0 vector. Okay, we want to prove answer is 0 vector. How many terms in LHS? Yes, there are 3 terms are there. What is the first term? Yes, AD vector. AD vector means A to D. Where is A to D from the diagram? Yes, very good. Join A to D, so which is AD vector. Okay, AD vector plus BE vector. Where is BE vector? Yes, BE vector is equal to, listen, which is BE vector. Yes, BE vector. Next, CF vector. Where is CF vector? Yes, which is CF vector. Yes, CF vector. One can write here also, AD vector. Listen, we want to prove AD vector plus BE vector plus CF vector is equal to 0 vector. Okay, what is DEF? Yes, they are the midpoints. D is the midpoint. E is the midpoint. And F is the midpoint. Okay, MP means midpoint. D comma E comma F are the midpoints of the sides BC, comma CA and AB respectively. Okay, now to prove. Listen. To prove. What do we want to prove? Yes, to prove AD vector plus BE vector plus CF vector equal to 0 vector. Okay, this result we want to prove. Okay, for which now any idea? Yes, AD vector first equation, BE vector second equation, CF vector third equation. Whether I want to add these 3 equations or subtract? Yes, I want to add because plus. So that is why adding these 3 equations I am going to get 0 vector answer. Okay, now first term AD vector. Where is AD vector? Listen from the diagram. AD vector is equal to, okay, to get a AD vector, which triangle I want to consider? Yes, AD vector is equal to AB vector plus BD vector. Which triangle I want to consider? In triangle ABD. In triangle ABD. So, now, in triangle ABD. In triangle ABD, AD vector, straight root. Okay, next way, yes, AB vector plus BD vector. AB vector plus DB vector. So, AD vector is equal to AB vector plus BD vector. So, AB vector, that is AD vector is equal to AB vector plus BD vector. AB vector plus BD vector. Okay. Now, where is AB vector? Listen, AB vector is that one side of the triangle. Okay. AB vector first term clear. What is a BD vector? Yes, BD vector. BD vector is not the whole side. where BD is the half of the side of BC, where D is a midpoint, therefore equal in magnitude. Therefore, here BD vector is equal to half of BC vector, because D is a midpoint. So, BD vector can be rewritten as BD vector is equal to half of BC vector. So, AB vector as it is, AB vector plus BD vector equal to, BD vector is equal to half of BC vector. Otherwise, BC vector by 2 also correct. So, BD vector equal to BC vector by 2. So, BC vector by 2. Let it be the first equation, whose left hand side is AD vector. So, first equation is ready. Okay, similarly, now I want to find a second equation from the second term. Okay, what is second term? BE vector. Yes. Now listen. Now, to get a BE vector, which triangle I want to consider? BE vector. Yes. BE vector is equal to BC vector plus CE vector. So, BE vector is equal to BC vector plus CE vector. Which triangle I want to consider? Yes. In triangle BCE. In triangle BCE. Okay. In triangle BCE, BE vector is equal to BC vector plus CE vector. So, BE vector is equal to BC vector plus, yes, CE vector plus CE vector. Okay, which is equal to, where is BC vector? Yes, BC vector is the one side of the triangle. But where is CE vector? Yes, CE vector is the half of the length of CA vector. Therefore, CE vector is equal to CA vector by 2. So, BC vector as it is plus, what is CE vector? CE vector is equal to CA vector by 2, which is second equation, whose left hand side is BE vector. Okay, second term completed. Now, I want to find third term. What is the third term? CF vector. Okay. And to find a CF vector, which triangle I want to consider from the diagram? CF vector. Yes. CF vector is equal to CF vector, straight root. Next root is CF vector is equal to CA vector plus AF vector. Which triangle? Yes. In triangle ACF or FCA. In triangle FCA. Now, in triangle FCA, see, we need CF vector. CF vector is equal to straight root CF vector. Next root is C to A plus A to F. So, CF vector is equal to CA vector plus AF vector. CA vector plus AF vector. Okay, which is equal to, what is the CA vector? Yes, CA vector is the left side of one side of the triangle, no problem, which is fixed. Okay, second term, CA vector as it is, because one side of the triangle. Next, AF vector. Where is AF vector? AF vector is the, yes, half of AB. So, AF vector is equal to AB vector by 2. So, CA vector plus AF vector is equal to, yes, AB vector by 2. AB vector by 2, which is third equation, whose left hand side is CF vector. Yes, 3 times ready. Now, listen, we want to prove sum of the 3 terms equal to 0 vector. Okay, now I want to add or subtract? Yes, I want to add, which means 1 plus 2 plus 3. That's, children listen, now adding 1 plus 2 plus 3, we get. Okay, sum of the LHS? Yes, AD vector plus BE vector plus CF vector. First AD vector. Listen, AD vector plus BE vector plus, yes, CF vector plus CF vector. Okay, which is equal to, yes, sum of RHS. What is first term? AB vector plus BC vector by 2. So, AB vector plus BC vector by 2 plus. Now, second equation. What is second equation? Yes, BC vector plus CA vector by 2. So, plus BC vector plus CA vector by 2 plus, yes, now third term. Third term is CA vector plus AB vector by 2. So, plus CA vector plus AB vector by 2. Okay, listen. Say first term plus second term plus third term. Okay, now yourself. Simplification yourself. Any idea? Yes. AB vector present how many places? Yes, 2 places. Listen. AB vector. Yes, AB vector. Okay, what is the total? Yes, it is 1 A vector. AB vector, and it is half of AB vector. Here 1 plus 1 by 2. Okay, listen the rough work. Rough work is 1 plus 1 by 2. 1 plus 1 by 2 equal to, yes, 1 and half. 1 and half equal to 3 by 2. Otherwise, 1 2 is 2. 2 plus 1 3. So which is equal to 3 by 2. So say 1 time of AB vector, and it is half time of AB vector. So 1 plus 1 by 2 equal to 3 by 2. Which means 3 by 2 into AB vector. Okay, similarly, come to second term BC vector. Yes, BC vector present how many places? Yes, 2 places. Listen. BC vector. Yes, BC vector. Here BC vector 1 time. And BC vector by 2. So here coefficient 1, here coefficient 1 by 2. What is the total? Yes, again 1 plus 1 by 2 equal to 3 by 2. So 3 by 2 into BC vector. Okay. Next, CA vector, CA vector. Yes, 2 places. CA vector. Listen. CA vector, CA vector. CA vector presented twice, where CA vector 1 time and CA vector by 2. It is half time. That is 1 plus 1 by 2 equal to 3 by 2. Which means here AB vector present 2 places. Total 3 by 2 AB vector. Next, BC vector present, yes, 2 places. Total 3 by 2 into BC vector. Next, CA vector present 2 places. So 1 plus 1 by 2 equal to 3 by 2, where 3 by 2 AB vector plus 3 by 2 BC vector plus 3 by 2 CA vector. So where 3 by 2 is common for our convenience. Now which is equal to 3 by 2 into, what is first term? Yes, AB vector. 3 by 2 into AB vector plus, where 3 by 2 common. Next, 3 by 2 into BC vector, where 3 by 2 common. So plus BC vector plus 3 by 2 into CA vector. 3 by 2 common. So CA vector. Okay. Now next step, yourself. Yes. Here 3 by 2. If I doubt means 3 by 2 going to multiply inside, we get a before step. 3 by 2 AB vector plus 3 by 2 BC vector plus 3 by 2 CA vector. Okay. Now we want to prove equal to 0 vector. Listen, here the center BB cancel, center CC cancel, center BB cancel, center CC cancel. First and last is the result. What is the first and last? AA vector. AA vector means what? Yes, A to A. Initial point A, terminal point A. So AA vector equal to 0 vector. So one can write directly center BB cancel, center CC cancel, first and last AA vector. AA vector equal to 0 vector because initial point and end point are same, therefore which is equal to 0 vector. AA vector equal to 0 vector. So the bracket equal to 0 vector. 3 by 2 into 0 vector equal to 0 vector, hence the result. One can write like that. Otherwise, if I doubt, we can write elaborate form also. 3 by 2 into. What is AB vector? Yes, AB vector equal to second minus first. AB vector equal to OB vector minus OA vector. AB vector is equal to OB vector minus OA vector. OB vector minus OA vector plus. Similarly, here after yourself. What is a BC vector? Yes, second minus first. OC vector minus OB vector. OC vector minus OB vector plus. What is a CA vector? Yes, second minus first. OA vector minus OC vector. So plus OA vector minus OC vector, complete the moon bracket. Okay, now simplification. Yes, plus minus cancel. Listen, plus OB vector minus OB vector cancel. Come to second term, minus OA vector. Next, yes, plus OA vector cancel. Next, plus OC vector. Next, minus OC vector. So plus minus cancel. So bracket, all the terms are cancelled. 1, 2, 3, 4, 5, 6 terms are there. All the 6 terms cancelled, whose answer is 0 vector. 0 vector into 3 by 2 is equal to 0 vector. That is 3 by 2 into 0 vector is equal to 0 vector into 3 by 2 is equal to 0 vector, whose left hand side is AD vector plus BE vector plus CF vector is equal to 0 vector. Hence proof. Children listen. Now 12th question from the first exercise. If ABCD is a quadrilateral and E and F are the midpoints of the diagonals AC and BD respectively, then prove that AB vector plus AD vector plus CB vector plus CD vector is equal to 4 times of EF vector. We want to prove. Okay, again come to the question. If ABCD is a quadrilateral and E and F are the midpoints of the diagonals AC and BD respectively, where AC and BD are the diagonals of a quadrilateral ABCD, then prove that AB vector plus AD vector plus CB vector plus CD vector is equal to 4 times of EF vector. That result you want to prove. Okay, what is the keyword first? Yes, quadrilateral is a keyword. Where given that ABCD is a quadrilateral, first let us draw the quadrilateral. Listen, step 1. Let us draw the quadrilateral. Listen, first let us draw the quadrilateral. Let A, B, C, D be a quadrilateral. Given that A, B, C, D is a quadrilateral. Step 1 over. Next, step 2. Yes, E and F are the midpoints of the diagonals AC and BD. So, first join AC, where AC is one diagonal. First join AC one diagonal. Yes, AC one diagonal. Next, BD is next diagonal. Next, join the diagonal BD. Join the diagonal BD. Yes. Now, AC and BD are the diagonals. Given that E and F be the midpoints of the diagonals AC and BD respectively. Here, approximately, one can take, suppose E is the midpoint of approximately this the point E is approximate. Approximately we want to consider. Let E is the midpoint of AC. Let E is the midpoint of AC. Next, let F is the midpoint of BD. Let it be here F, where F is the midpoint of BD. Here we are considering F is a midpoint approximately, not accurately, approximately. Okay, that's all. Now, say ABCD is a quadrilateral, then E is the midpoint of AC and F is the midpoint of BD. 3% over. Next, come to the question. First, AB vector. So, where is AB vector from the diagram? Yes, AB vector equal to, listen, AB vector is equal to straight root to AB vector. And what is the next root? Yes, AE vector plus EF vector plus FB vector. So, the first term AB vector is the first term, first equation, AD vector second equation, CB vector third equation, and CB vector third equation, CD vector fourth equation. Adding 4 equations, we are going to get a record result in which first term AB vector is equal to AE vector plus EF vector plus FB vector, first equation. And here consider every time we want to move E to F, so that is very important. So join EF, because the record result we need EF vector, 4 times of EF vector. Therefore, every time we want to move E to F, so that is very important. Now listen, AB vector is equal to AE vector plus EF vector plus FB vector, which is the first equation. Okay. Now, listen, first term AB vector. AB vector is equal to AB vector is equal to AE vector plus, okay, AB vector is equal to AE vector plus EF vector, see E to F, EF vector plus EF vector plus FB vector, okay, plus FB vector. Let it be the first equation. Children listen, here center EE cancel, center FF cancel. Consider first and last. Yes, first and last AB vector. Yes, your answer is correct. Okay. Now come to second term. What is AD vector? Second term is AD vector. Now listen. AD vector is equal to from the diagram. Where is AD vector? Yes, listen, AD vector. Okay. AD vector is equal to, yes, AE vector plus EF vector plus FD vector. Okay, FD vector. So AD vector is equal to AE vector plus EF vector plus FD vector. FD vector, second equation. And here also center EE cancel, center FF cancel, first and the last. First and the last FD, AD vector. Yes, AD vector is correct your answer. And here remember, every time we want to move E to F, that is very important. Okay, now come to third term, CB vector. Where is the CB vector? Yes, CB vector, listen, CB vector. Yes, CB vector. CB vector is equal to, yes, CE vector plus EF vector plus FB vector. Very good. Listen, CB vector equal to CE vector, that is CB vector. CB vector is equal to CE vector plus EF vector plus FB vector. FB vector, which is third equation. Remember here also, center EE cancel, center FF cancel, first and the last, CB vector. Yes, first and the last CB vector. Yes, your answer is correct. What is the third term? CD vector. Where is the C to D? That is CD vector means C to D. Where is the C to D? Yes, C to D. CD vector. Listen, CD vector is equal to CE vector plus EF vector plus FD vector. Okay, CD vector equal to CE vector. So CD vector. CD vector is equal to CE vector plus EF vector plus FD vector. FD vector, which is fourth equation. Okay. Remember, left hand side I need 1, 2, 3, 4 terms. Yes, we have 4 equations. Now I want to add or subtract? Yes, I want to add. Which means 1 plus 2 plus 3 plus 4. 1 plus 2 plus 3 plus 4. Okay, sum of the LHS. Please sum of the LHS. Very good. That is AB vector plus AD vector plus CB vector plus CD vector, which is equal to. Okay, sum of LHS over. Now we want to prove RHS equal to 4 times of EF vector. Okay, I want to add this RHS fully. Any idea to add? Yes, very good. Listen, adding centers. Listen, adding centers. See, EF vector, EF vector, EF vector, EF vector. So add these 4 times EF vector, EF vector, EF vector, EF vector, EF vector, EF vector. How many times EF vector present totally? Yes, very good. 4 times of EF vector. So our required answer 4 times of EF vector is completed. That is EF vector plus EF vector plus EF vector plus EF vector is equal to 4 times of EF vector is ready. And remaining we have first column and the last column, which the vectors are going to cancel. So okay. Now, say consider the first column. Here, AE vector, how many times? Very good, twice. So 2 times of AE vector. Next, CE vector, how many times? Yes, 2 times of CE vector. Here, AE vector, E is common point. CE vector, E is common point. And what can you say about AE vector and CE vector? Yes, come to the lesson. Listen, AE vector and CE vector are equal in magnitude but opposite in direction, because already CB vector is equal to CE vector plus FB vector. Therefore, here E is the midpoint. Okay, E is the midpoint. Therefore, CE vector is equal to AE vector, equal in magnitude. but opposite in direction. Okay. Here AE and CE, see AE vector and CE vector are equal in magnitude but opposite in direction. Come to the last term. Listen, FB vector twice and FD vector twice, where F is a common point. F is a common point. FB and FD. What can you say about FB and FD? Listen from the diagram. Listen, FB and FD are equal in magnitude but opposite in direction because F is a midpoint. So FB and FD are equal in magnitude but opposite in direction. So I want to group. So AE vector, CE vector, one group, and FB vector, FD vector, one group. So that's all. Now listen, twice of AE, twice of CE, where 2 is common. Okay, so twice of AE vector plus CE vector, which is one group. Why? Because we are grouping these two one group. Yes, E is the common point. That is important. Plus twice of. Next, FB vector twice, FD vector twice. So these two one group. So FB vector plus FD vector. That's all. Okay. Next, which is equal to 4 times of EF vector plus twice of AE vector plus CE vector. Okay, from the diagram, AE vector, CE vector. Where is AE vector? Yes, AE vector plus CE vector. Here CE vector equal to, yes, minus AE vector because equal in magnitude, opposite in direction. So AE vector fixed plus CE vector is equal to minus AE vector. Okay? CE vector is equal to minus AE vector. Listen, from the diagram, CE vector is equal to minus AE vector because opposite direction equal in magnitude plus twice of FB vector fixed. And what is FD vector from the diagram? Yes, listen, FD vector and FB vector are equal in magnitude but opposite in direction. Therefore, FB vector fixed and FD vector is equal to minus FB vector. So FD vector is equal to minus FB vector, complete, where plus AE minus AE cancel, plus FB vector minus FB vector cancel. Now 2 into 0 vector plus 2 into 0 vector equal to 0, no name. So which is equal to 4 times of EF vector, hence proved. Because plus 0 plus 0, no need to write. Now write question with answer. Therefore, AB vector plus AD vector plus CB vector plus CD vector, which is equal to 4 times of EF vector. So hence proved.